Okay, guys, so let's take a look at the second half of 9.3. The previous lecture covered the first five chemical equations here. We're going to balance the rest of these. And this is sort of the tougher half of these. These are a little harder. So let's start with this one, number 6. Number 6. Okay, so my first step when I balance chemical equation, again, is to draw a line. Right? This helps me balance. It helps me put the same number of stuff on both sides. And of course, since I've already given you the 5 O2s, I'm going to start there. So 5 times 2 tells me that on this side I have 10 oxygens. 10 oxygens. And this is an O, not a 0. I know that gets confusing. So then I need to have 10 oxygens over here. Okay. And to have 10 oxygens over here, whether there's 5 in this molecule, so each molecule has 5 oxygens, and I need 10 total. So I need 2 molecules. Okay, need 2 molecules. That gives me my 10 oxygens. Now, if I have 2 of these molecules, that's going to give me 2 times 2 phosphorus. So that's going to give me 4 phosphorus. So I need to have 4 phosphorus over here. 4 phosphorus. And look, phosphorus is on its own right here. So 4. And that balances. It balances pretty simply. That one wasn't so bad. All right, number 7. Okay, use different colors so we don't get mixed up. Number 7, we're going to draw our line down through here. And you'll notice I didn't give you guys any numbers here, except for right here I did. Okay, this is the same as saying 1 potassium bromide, 1 KBr, right? So this tells me I have 1 potassium, I have 1 bromine here. Okay, so I need 1 potassium. Why potassium has the symbol K, we're not going to get into right now, but it does. So I have 1 potassium and 1 bromine on both sides. Now I need to make that over here. So 1 potassium, I could just make that with this. And 1 bromine, well, this is the only molecule I have with bromine, so I'll make 1 of those. Okay, and that's also going to give me 1 magnesium. So I need to make 1 magnesium over here. And this is the only molecule I can have that. So now we are balanced. It is 1, 1, 1, and 1. We're going to see in the next section that this is a single replacement reaction. If you guys have already moved on to 9.4, you'll know this is a single replacement reaction because the potassium replaces the magnesium in this equation. The potassium steps in and it kicks out the magnesium, and they trade. We'll get into that a little more later. Okay, number 8. Number 8, we have the synthesis of peroxide. Some of you guys might remember having peroxide poured on a cut on your knee. You scrape your knee as a little kid. And you say, Mom, please don't use peroxide. Please don't use peroxide because it stings. But we're going to try the synthesis of this, okay? Now, I have oxygen in this molecule and in this molecule. And so balancing these by starting here is going to be tough. So I'm going to try over here. Okay, and I'm going to take a guess. I'm going to say, what if we have 6 of these, right? And we know that's wrong. I'm taking a wrong guess here. 6 of these. If I have 6 of these, that's going to give me 6 times 2. It's going to give me 12 hydrogens. 6 times 2, it's going to give me 12 oxygens. Okay, so we're going to go over here, and I need to make 12 hydrogens. The only thing I have hydrogen in over here in my reactants is water. So I need 6 waters to give me that 12 hydrogens. Okay. And then I need 12 oxygens. Okay, so I have 6 times O gives me 6 oxygens here. And I need 6 more. So I need 3 pairs. That's going to give me 6 more oxygens, right? So I have 12 hydrogens and 12 oxygens now. And it's balanced. It is balanced, but look how big these numbers are. Okay. big. Well, look how big these numbers are. I think that I started with 3 times as much peroxide as I needed. That's my guess. So I'm going to start over, and instead of saying 6 peroxides, I'm going to say 2 peroxides. And we'll try to start from there. So if I have 2 peroxides, that's 2 times 2 hydrogens, 4 hydrogens. 2 times 2 oxygens, that gives me 4 oxygens. Okay. If I want to have 4 hydrogens over here, I need to have 4 hydrogens in my reactants. Okay. The only place to get that is going to be here with water. So 2 times 2 hydrogens would give me that. So 2 waters will give me 4 hydrogens. Okay. And I still need 4 oxygens. So 2 of them are going to come from the water. And then I'm going to need some extra oxygen to balance to give me my 4 oxygens on this side. So 2 from oxygen and 2 from the water. What I'm telling you right here is that if you take water and you add pure oxygen, that you will get peroxide. You will get peroxide, the same stuff that you use to clean out your knee. It's just water with extra oxygen in it. It's kind of interesting. I think it's kind of interesting. I'm a science teacher. Okay, we'll scroll down a little bit here. So I've got room. Okay, we're going to do the decomposition of gasoline. And actually, I'm going to make some space in the document here so I can see what I'm doing. All right, decomposition of gasoline. So again, I'm going to draw my line, right? And then I've given you some of the data you need. I've told you that you have 25 times 2 oxygens, right? So I have 50 oxygens. And I have 2 times 8 carbons. That's 16 carbons. So if you struggled with this one, maybe you struggled with your times tables a little bit, right? That's fine. You can use a calculator if you need to. And I have 2 times 18 hydrogens. Okay, gasoline has 18 hydrogens in it. 2 times 18 is 36 hydrogens. Well, now that I've got 50 oxygens, 16 carbons, and 36 hydrogens, I just need to make that out of my CO2 and my H2O over here. Since oxygen exists in both places, I'm not going to start with oxygen. I'll probably do it last. I have 2 different compounds with oxygen. So let's start with carbon. Okay, I need 16 carbons. Okay, 16 carbons. So carbon comes 1 at a time in carbon dioxide. So I'll just make 16 of those. Okay, that's going to give me my 16 carbons. Next, let's do hydrogen. So I have 36 hydrogens. Okay, and I got that by multiplying 2 times 18, right? So here, hydrogen comes 2 at a time. Okay, so 36 divided by 2, I've already got that here, right? 36, 18, and 2. 2 and 36 gives me 18, right? 18 waters will give me 36 hydrogens. And we can check that with a calculator, right? 18 times 2 equals 36, right? Just like over here, 2 times 18 equaled 36. So we end up with the same hydrogens on both sides. And I'm betting that this is balanced. If it's not balanced, then there was a problem with the way it was written. Now I need to make sure that I have 50 oxygens, okay? So I have 60 O2s. I'm sorry, I have 16 O2s, right? So 16 times 2, that's 32 oxygens. That's not 50. Oh, but I have some more oxygens over here in the water that I had. So 18 times 1 is 18 oxygens. And then 32 and 18 make 50. So I have 50 oxygens. Well, that's what I have on both sides. I have 50 here, 50 here. I have 16 carbons, 36 hydrogens, 36 hydrogens. This is balanced. This is a balanced chemical equation. When you burn gasoline, you take gasoline, you add 25 parts of oxygen, And it gives you 16 carbon dioxides and 18 waters every time you burn gasoline. Did you know that water comes out the tailpipe of your car? Right here it is in a chemical equation. It tells you that. Water is one of the products of combustion. Okay. Now, we're going to look at cellular respiration. And this one seems tough. It seems tough. But really, it's just the same thing we've been doing with bigger numbers. Okay. We're going to draw our line through our arrow. Okay. And we're going to guess and check. We're going to guess and check. And I think oxygen is going to be a bad place to start. I have oxygen here, and oxygen here, oxygen here, and oxygen here. Okay. So I'm going to guess that I should start with carbon. Okay. Carbon exists here and here. And if I have a molecule of this is actually sugar, right? C6H12O6. We've seen that before in our earlier notes, but here we see it is sugar. I'm going to guess that I'm going to use a good guess and not a bad one because I don't want to take you down that road. The numbers get too big. I'm going to guess that I have one molecule of sugar. I have one C6H12O6. If I have one of those, that means I have 6 carbons. I have 12 hydrogens. And I have 6 oxygens. I know I'm going to have more oxygens from this. So this will end up getting erased. But that's okay. So for now, I need to make 6 carbons and 12 hydrogens on this side. To make 6 carbons, okay, carbon dioxide has carbon 1 at a time. So that means I have 1 carbon dioxide. I'm sorry, that doesn't mean I have 1 carbon dioxide. It means I have 6 carbon dioxides. 6 CO2s will give me the 6 carbons that I need. Okay. If I have 6 CO2s, that's going to give me 6 times 2. It's going to give me 12 oxygen. Right. We'll hang on to that because we know that we're going to get more oxygen from this water over here, right? Next, I want to make sure that we have the same hydrogens on both sides. So I have 12 hydrogens here. It's not going to come from the carbon dioxide. It must come from the water. To get 12 hydrogens from water, I would need, there's 2 here, so 12 divided by 2, I need 6 waters. 6 waters is going to give me my 12 hydrogens. So my carbons are taken care of. My hydrogens are taken care of. Oxygen, we need to balance that still. So I have 6 times 2, it's this 12 oxygens. And then I have 6 times 1, I have 6 more oxygens. Okay. And then we're just going to put these together. So 12 and 6 gives me 18 oxygens. So I have 18 oxygens on this side. I need to make 18 oxygens on this side. I already have 6 of them. Okay. So 18. Take away the 6 I already found. It's going to give me 12 oxygens, right? So I need to make 12 more oxygens. Okay. And I can do that with my O2. This is how much oxygen needs to go into this reaction. This is how much oxygen I need to combine with 1 sugar to do cellular respiration. So I need 12. They come 2 at a time. So I need 6 O2s. Now, what this chemical equation is telling you is that if you have one molecule of sugar and 6 molecules of dioxide of oxygens, it will give you 6 molecules of carbon dioxide and 6 molecules of water. That's what this equation tells us. Hopefully this gives us some insight into how we're going to balance chemical equations. On the test, we're not going to deal with anything this complicated. At least we won't be balancing anything this complicated, but I thought it would be worth it for us to do that at least once. Okay, so that we can see what that process looks like. To learn more about balancing chemical equations and to get into more complicated equations, that is certainly something we could learn in a chemistry course. All right.